This lesson is about circles and arcs, and we've got two objectives. The first one is to find the measures of central angles and their corresponding arcs. And the second objective is to be able to find the circumference of a circle and tie that into something that is called arc length. All right, let's start off by defining exactly what a circle is. A circle is a set of points that are all equidistant from a given point, and we call that given point the center. Every circle has a degree measure of 360 degrees. Within a circle, we have different things known as diameter, which is the measurement from one side of the circle to the other through the center. Half of that diameter is known as the radius, all right? And then we have this idea of what are called congruent circles. These are circles that are equal in measure, and the way that we know that they're equal in measure is that their radii are the same. All right, and then we come across this one new thing here that is known as a central angle. Now, what a central angle is, very simply, is by its name, it starts here at the center. It is an angle of a circle or within a circle whose vertex is on the center of the circle. All right, and we're going to sometimes refer to that as theta. Remember, that's this Greek letter, kind of like this, okay? We're going to refer to that as theta, all right? And one of the things that we're going to learn about a central angle is a central angle is what we call equal to its intercepted arc. So in other words, if the angle here would be 40 degrees, then on the rim, the distance from A to B right in here, that part of the arc is known as its intercepted arc. It's kind of what the angle can bite off on the rim of the circle. If the angle is 40 degrees, the arc is 40 degrees. All right? And that's what we're talking about here. The arc of the circle is a certain portion or part around the rim of the circle, okay? Now, there are three specific kinds of arcs that we're going to be looking at. You've got a semicircle, which is half a circle, all right? We've got a minor arc, which is an arc whose measurement is less than half the circle, and a major arc whose measurement is greater than half the circle. So let's start off with the first one. And the first one is a semicircle. In each of these three circles, I have to know what the center is. Now, if the center is being intercepted by a segment, we call that segment a diameter. What that does is it splits the circle into two equal pieces, all right? And each of these is known as a semicircle. Now, when you're naming a semicircle, you're going to want to use three letters. And if I just put A and B there, you can kind of see why. I want to name the arc that I kind of did the squiggly lines on. If I call it arc AB, you don't know whether I'm talking about the arc with squiggly lines or the underneath part of the circle down through here. All right? So whenever I am naming an arc that's 180 or larger, I need to have a pathway. So this would be known as arc ACB, where it starts, where it stops, and a point that it passes through. We put a little arc symbol over the top of it. So this semicircle is known as arc ACB. If we talk about a minor arc, let's sketch a minor arc here. So let's say that from the center here, I have a central angle that looks something like that, okay? I know that its intercepted arc is this portion right over here. And because I know that minor arcs have to be less than 180 degrees or less than a semicircle, I can simply call this arc AB. I only need its starting and its stopping point. Similarly, if I were to draw a very similar angle here, and I called this these endpoints A and B. And I wanted to name this part of the circle, this part of the rim of the circle, all right? First of all, that's what's called a major arc. It's more than half the circle. In order for me to name it, though, I need an additional point on there, call this C, so that I can tell you arc ACB. Or I could have named it arc BCA. I tell you where it starts, where it stops, and a point to give me direction, a point it passes through. All right? So, next thing that we're going to talk about is arc measure. How do you measure that arc? All right? And it starts off by saying the measure of a minor arc is equal to the measure of its corresponding central angle. If you paid attention, that's what I said earlier. A central angle is equal to its intercepted arc. All right? The second one says the measure of a major arc is the measure of the related minor arc subtracted from 360. So let's talk about that for a second. What they're saying is we know that one trip around the circle is 360 degrees. If you know a portion of that in a minor arc, take 360 minus the minor arc to find the major arc. The third part about arc measure is the measure of a semicircle. It's always 180 degrees. Why? A diameter will split the circle in half. Okay? Some more terminology. We have this concept of what is called adjacent arcs. These are arcs of the same circle that share a point in common. In other words, like you put the two arcs together and it gives you a bigger arc. All right? This postulate for arc addition actually describes this pretty well. Arc AB and arc BC would be known as adjacent arcs. And what we're able to determine by throwing in this idea of arc addition, just like how we had angle addition and how we had segment addition, we know this to be true, that arc ABC is comprised or made up of arc AB plus arc BC. And that's what the arc addition postulate tells us. All right, so let's take a look at some examples. Let's try some of these. First thing it says, here's a picture, and I want you to find these 6 different arc measures. All right, so let's start with the basic one that they gave us here. What's the measure of arc TC? Well, in order to find that arc TC, I need to know its central angle. The central angle there is 128. Therefore, the corresponding minor arc is 128 degrees. Yes, it's important to put the degree symbol on there. All right. The second one they want me to find is what is the measurement of arc BTC? Well, let's see. We already said this arc up here is 128. I know that arc BT can be found because its central angle is 90 degrees. So this arc is 90. I know that BTC, arc BTC, is made up of arc BT plus arc TC. So I'm going to say 90 plus 128. And if I add those correctly together, I get 218 degrees. It makes sense. That's more than 180. They use 3 letters. A major arc is equal to 218 degrees in this case. All right. What about arc CD? Well, arc CD over here, I don't know its corresponding angle, central angle here. But one thing that I do know is that 128 and the angle right next to it have to be supplementary. So if I take 180 minus 128, I'm going to get 52 degrees. I know this angle in here is 52. If that angle is 52, its corresponding arc must also be 52 degrees. All right, couple more here. TCD. Now notice they give me a middle letter there, so they're giving me direction. TCD. I notice that T and D are the endpoints of a diameter. So that tells me that arc TCD around the rim is a semicircle. All semicircles are 180 degrees. How about TDC? They're using the same 3 letters, but they changed the order. TDC is actually made up of T BD, 180 degrees, plus DC, which is 52 degrees, which would give me a major arc here of 232 degrees. Now, how about arc B all the way around through C to D? Again, B all the way around through C to finish out at D. Holy cow. Well, I'm going to do a different approach for this. I know that these two angles inside here, this angle is going to be 90, which means that arc is 90. One thing I know is a full trip around the circle is 360 degrees. I'm going to take off arc BD, which tells me that arc BCD would be 270 degrees. All right. The next thing we're going to talk about is circumference. How do you find the circumference of a circle? Well, the circumference of a circle is the perimeter of the circle. All right. But we use some different formulas for circumference. One that you guys might be familiar with is circumference is equal to 2 pi r. Now, that formula works fine. Not a problem. I, in particular, really prefer to use this formula. I know that we previously defined a diameter as being half a radius. So 2 times a radius is the same thing as the diameter. And I call this d pi. Both of these formulas, either one of them works perfectly to find the circumference of a circle. I am going to focus for this lesson on using d pi. Now, what is pi? Well, everybody always says if they give you pi, it's 3.14, or you might learn it as a fraction 22 over 7. The true definition of pi is found by actually solving this equation right here. Pi is defined as the circumference of a circle divided by its diameter. All right? Now, in our work that we're going to do, sometimes they will say, write the answer in terms of pi. That means we're not going to use any approximation for pi. They could say use pi as 3.14, specifically use 3.14. They could say pi is 22 over 7, specifically use 22 over 7. Or they could say approximate and round, and they don't give you an approximation for pi. If that's the case, you want to use the pi button on your calculator. All right, which gives us a greater approximation of pi. Next term today, concentric circles. What concentric circles are, very simply, is these are 2 or more circles that have the exact same center. And they have to be on the same plane. All right? Next term, here we go. Arc length. Arc length is very simply a fractional part of the circumference of a circle. Now, I defined it here as the length of an arc of a circle is the product of the ratio of the measure of the arc divided by 360 and the circumference of the circle. All right, let me kind of write this a little bit differently for you. I know that arc length, I'm going to abbreviate it AL, is equal to theta divided by 360. Theta is the measure of the arc divided by 360 times d pi. D pi represents the circumference of the circle. Now, this is the formula that I like to use whenever I'm asked to find arc length. I think it's the easiest way to do it, and it involves the least amount of work. All right? So let's start off, first of all, by finding the circumference of a couple of these circles. Whenever I'm given a circle and asked to find circumference, or eventually we're going to get into area, we're going to talk about arc length here, okay? The first thing I do whenever I'm dealing with a circle is I identify what they give me. In this circle, they give me a diameter of 20. Now, because they want me to find circumference, I know circumference is d pi. They tell me in the directions to leave my answer in terms of pi. Well, shoot, this is really easy. The circumference is equal to 20 pi centimeters. Don't forget to label it. That's it. There's nothing else to do. They want the answer in terms of pi. Now, if they had said round this to the nearest hundredth, then on my calculator, I would have taken 20 times pi. All right? In the second example here, they give me a radius. I know the radius is 3. I can use 2 pi r, but I just say, you know what, let's make it easier. If the radius is 3, the diameter is 6. The circumference is d pi. So then I know that the circumference, very simply, is 6 pi feet. All right? What about finding the length of an arc? Now notice they talk about finding the length. How do I know it's the length of an arc? Because there's the word arc. They specifically are showing me in red what they want us to find, and they want the answers left in terms of pi. Now, what arc length is, remember again, it's a fractional part of the circumference. So I'm finding the circumference, but only a part of it. The whole, without taking the part of it, that would just be find the circumference. All right? In this problem, the first thing I want to do is recognize that the radius is 14. I know my formula for circumference is d pi that I like to use, so I'm going to change this to 28. Double the radius is the diameter. I know that the theta that they give me here is 45. So to find the arc length, I'm going to take 45 out of 360. That's the fractional part of the entire circle times 28 pi. Now, there's a few ways that you can do this from here. You can simplify by hand. For example, I know that 45 out of 360 is really 1/8 times 28 pi, which would be 28 over 8 pi, which would be, let's see, both are divisible by 4, so that would be 7 over 2 pi centimeters. All right, that's my arc length. But I could also ask my graphing calculator to help me with this, and I can go 45 divided by 360, get that answer, times my diameter, which was 28, get that answer, and then write it as 3.5 pi, or watch this. If I go math, enter, enter, it's going to change it to a simplified fraction, 7 over 2. So the arc length here is 7 over 2 pi centimeters. All right, take a look at the next one. Now notice in red here, they gave us a bigger arc. So I'm going to have to do a little bit of thinking here. The first thing is they give me a radius of 18. I don't want the radius, I want the diameter. Diameter would be 36. Got it. Okay. I know that this red arc is actually 270 degrees. I know that because this central angle is 90, which means this arc is 90, and the red arc is everything but that arc. So I took 360 minus 90 to get 270. To find the arc length, I'm going to take 270 out of 360 times 36 pi. All right, now I'm going to go ahead and use the calculator this time. I've got 270, not times, divided by 360. I get that answer, 0.75 times 36. And, oh, it worked out nicely, so this is just simply 27 pi meters. Make sure, again, that we are labeling things. All right, a couple more examples here. In this particular example, they give me the diameter. I know that the diameter is 23. I know that my red arc here would be 180 degrees. All right? So to find the arc length, it's the fractional part of the circle. 180 over 360 times the diameter times pi. Well, I know 180 out of 360 is 1/2. So I could say that the arc length here would be 23 over 2 pi meters. All right, well, what about one example like this? So they give me this picture, and I notice that this arc is 25. but the arc that they want me to find is directly on the other side of the circle. I know if that arc is 25, this angle is 25. I know because vertical angles, even in circles, vertical angles are congruent. I know that this angle over here has to be 25, which means that this missing arc here has to be 25. In the problem, they give me a radius of 9, half of that diameter, so the diameter here would be 18. To find the arc length, I'm going to take theta, which in this case is 25, out of 360 times 18 pi. And again, they want me to leave the answers in terms of pi. I'm going to have my calculator help me out. 25 divided by 360. Get that answer and multiply that times 18. Get that answer and then change it. Hopefully you recognize what it is already. Math, enter, enter. We'll change it into a decimal, make my life easier, and I get the arc length is 5/4 pi, or my units here, meters. I hope this video helps you. Please complete Math Excel and let me know if you have any questions.